In the beginning, the Earth takes shape. It was a time of unimaginable chaos and raw energy, a time when the very fabric of space and time was still settling into the patterns we recognize today. The Earth, as we know it, was just a dream in the cosmos, waiting to be realized. Imagine a time, before our planet even existed. The universe was a vast expanse of emptiness, punctuated by the occasional burst of light from distant stars. It was a canvas of potential, waiting for the brushstrokes of creation to bring it to life. Billions of years ago, there was only a swirling cloud of dust and gas. This cloud, known as a nebula, was a chaotic mix of particles, each one a tiny fragment of the universe's grand design. It was a place of constant motion, where gravity and other forces played a delicate dance. This cloud, called a nebula, was the birthplace of our solar system. Within its depths, the seeds of planets, moons, and stars were sown. It was a cosmic nursery, where the building blocks of our world were slowly coming together. Over millions of years, gravity pulled the dust and gas together. This force, one of the fundamental interactions of the universe, acted like a cosmic sculptor, shaping the raw materials into more complex forms. The particles began to clump together, forming larger and larger masses. The particles clumped and swirled, eventually forming a hot, spinning disk. This disk, known as a protoplanetary disk, was a chaotic whirlpool of matter, with temperatures soaring to unimaginable heights. It was within this fiery cauldron that the planets of our solar system began to take shape. At the center of this disk, the sun ignited, blazing with nuclear fusion. This event marked the birth of our star, a massive ball of burning hydrogen and helium that would become the heart of our solar system. The sun's intense energy and gravity began to influence the surrounding material, pushing and pulling it into new configurations. The sun's intense heat and gravity pushed the remaining dust and gas outward, where they collided and stuck together. These collisions were violent and chaotic, with particles smashing into each other at high speeds. Over time, these collisions led to the formation of larger and larger bodies. These clumps grew larger and larger, forming planets, moons, and asteroids. Each of these bodies was a unique creation, shaped by the forces of gravity, heat, and motion. Some would become the rocky planets of the inner solar system, while others would form the gas giants of the outer reaches. Among them was our Earth, a hot, molten ball of rock. In its early days, the Earth was a hellish place, with temperatures so high that the surface was a sea of molten lava. Volcanic activity was rampant, with eruptions spewing ash and gas into the atmosphere. Over time, the Earth began to cool. This cooling process was slow and gradual, taking millions of years. As the surface temperatures dropped, the molten rock began to solidify, forming a crust. This crust was the first solid ground on our planet, a foundation upon which the future would be built. The molten rock solidified into a crust, punctuated by erupting volcanoes. These volcanoes played a crucial role in shaping the early Earth, releasing gases and minerals that would become part of the atmosphere and oceans. The landscape was constantly changing, with new landforms being created and destroyed by volcanic activity. Water vapor, released from the cooling rocks, condensed in the atmosphere and fell as torrential rain. This rain was unlike anything we experience today, with massive storms drenching the surface for thousands of years. The water began to collect in low-lying areas, forming the first bodies of water. The rains filled the Earth's basins, creating the first oceans. These early oceans were the cradle of life, providing a stable environment where the first simple organisms could begin to evolve. The water also played a crucial role in shaping the planet's surface, eroding rocks and creating new landforms. Thus, from chaos, our planet was born. The Earth we know today is the result of billions of years of change and evolution, a dynamic and ever-changing world that continues to shape and be shaped by the forces of nature. From its fiery beginnings to the present day, the story of our planet is a testament to the power of creation and the beauty of the natural world. A world in its infancy, the Precambrian Eon. This eon represents the earliest chapter in Earth's history, a time when our planet was just beginning to take shape. Imagine a world so different from the one we know today, a world where the very building blocks of life were just starting to form. The Precambrian Eon is a testament to the incredible changes and developments that have occurred over billions of years, leading to the diverse and vibrant planet we inhabit now. The Precambrian Eon stretches back to the very beginnings of the Earth, about 4.6 billion years ago. This immense span of time is divided into three major eras: the Hadean, the Archean, and the Proterozoic. Each of these eras represents a significant phase in the development of our planet, from its fiery molten beginnings to the emergence of the first complex life forms. The Hadean era, named after the Greek god Hades, was a time of intense heat and volcanic activity, with the Earth's surface constantly reshaped by powerful forces. It is a vast expanse of time, encompassing nearly 90% of Earth's history. During the Archean era, the Earth's crust began to cool and solidify, forming the first continents and oceans. This era also saw the appearance of the earliest known life forms, simple single-celled organisms that thrived in the harsh conditions of the young planet. The Proterozoic era, which followed the Archean, was marked by significant geological, atmospheric, and biological changes, setting the stage for the explosion of life that would come in the following eons. During this eon, our planet was a vastly different place than it is today. The surface was dominated by volcanic landscapes with vast stretches of barren, rocky terrain. The atmosphere was thick with gases like methane, ammonia, and carbon dioxide, creating a hostile environment for life as we know it. The oceans, too, were very different, filled with acidic waters and lacking the oxygen that is so crucial for most modern life forms. Despite these harsh conditions, the Precambrian Eon was a time of incredible transformation and innovation. The atmosphere was thick with volcanic gases, the land was barren and rocky, and the oceans were hot and acidic. These extreme conditions were the result of constant volcanic activity, which released vast amounts of gases and minerals into the environment. The Earth's surface was a dynamic and ever-changing landscape, shaped by powerful geological forces. Volcanic eruptions, tectonic movements, and meteorite impacts all played a role in shaping the young planet, creating a world that was both hostile and full of potential. Yet, even in this harsh environment, life emerged. The first life forms were incredibly simple, single-celled organisms that were able to survive and thrive in the extreme conditions of the early Earth. These organisms, known as prokaryotes, were the pioneers of life, laying the foundation for all future biological diversity. They were able to harness the energy from their surroundings, using chemical reactions to fuel their growth and reproduction. This remarkable ability to adapt and thrive in such a hostile environment is a testament to the resilience and ingenuity of life. The first life forms were simple, single-celled organisms similar to bacteria. These early organisms were incredibly diverse, with a wide range of metabolic strategies that allowed them to exploit different niches in the environment. Some were able to use sunlight to produce energy through a process known as photosynthesis, while others relied on chemical reactions to fuel their growth. This diversity of life forms and metabolic strategies was crucial for the development of more complex life, as it allowed for the gradual accumulation of genetic and biochemical innovations. They thrived in the primordial oceans, feeding on chemicals released from volcanic vents. These hydrothermal vents, located on the ocean floor, were rich in minerals and provided a stable source of energy for the early life forms. The extreme conditions around these vents, with high temperatures and pressures, created a unique environment that was ideal for the development of life. The organisms that lived around these vents were able to harness the energy from the chemical reactions taking place, using it to fuel their growth and reproduction. These early organisms were pioneers, paving the way for all life that would follow. Their ability to adapt and thrive in such a hostile environment was a crucial step in the development of more complex life forms. Over time, these simple organisms evolved and diversified, giving rise to a wide range of life forms with different metabolic strategies and ecological niches. This process of evolution and diversification was driven by the constant changes in the environment, as well as the interactions between different organisms. Over billions of years, these single-celled organisms evolved and diversified. This process of evolution was driven by the constant changes in the environment, as well as the interactions between different organisms. Natural selection played a crucial role in shaping the diversity of life, as organisms that were better adapted to their environment were more likely to survive and reproduce. This led to the gradual accumulation of genetic and biochemical innovations, which allowed for the development of more complex life forms. Some developed the ability to photosynthesize using sunlight to produce energy. This process, known as photosynthesis, was a major breakthrough in the history of life, as it allowed organisms to harness the energy from the sun and use it to fuel their growth and reproduction. Photosynthetic organisms, such as cyanobacteria, played a crucial role in transforming the Earth's environment as they released oxygen into the atmosphere as a byproduct of photosynthesis. This gradual increase in atmospheric oxygen had a profound impact on the development of life, paving the way for the evolution of more complex organisms. This process released oxygen into the atmosphere, slowly transforming the Earth's environment. The increase in atmospheric oxygen had a profound impact on the development of life, as it allowed for the evolution of more complex organisms that relied on oxygen for their metabolism. This process, known as the Great Oxidation Event, marked a major turning point in the history of life, as it paved the way for the development of more complex ecosystems and the eventual emergence of multicellular life forms. The gradual increase in atmospheric oxygen also had a significant impact on the Earth's climate and geology, as it led to the formation of the ozone layer, which protected the planet from harmful ultraviolet radiation. The Precambrian Eon set the stage for the explosion of life that would characterize the next era. The incredible changes and developments that took place during this eon laid the foundation for the rich and diverse ecosystems that we see today. From the emergence of the first simple life forms to the gradual increase in atmospheric oxygen, the Precambrian Eon was a time of incredible transformation and innovation. As we look back on this ancient chapter in Earth's history, we are reminded of the resilience and ingenuity of life, and the incredible journey that has led to the world we know today.